Welcome back. In this video, we're going to go over section 9.2, which is about how you can use completing the square to solve quadratic equations. So up until this point, we've seen that if you have particular quadratic equations where you get lucky and are able to factor, then you can solve by factoring and using the zero product property. We've seen that if the equation is in a particular form, you can use the square root property, like the one shown here in blue, y minus 4 squared equals 9. But we want to know, what do you do if it is just some kind of any old quadratic equation and doesn't happen to be in that form? It turns out that completing the square is just what you need in order to get this done. And it turns out that after completing this section, you'll be able to solve any quadratic equation at any time. So that's pretty exciting. So in order to get us ready to do completing the square, we need to look at and review the binomial square formulas a little bit. So binomial square formulas look like this. There's two of them, a plus b squared and a minus b squared. For a plus b squared, both of them are going to give you trinomials. You get a squared plus 2ab plus b squared for the first one, and a squared minus 2ab plus b squared for the last one. So the only difference is that in that first sign, is it plus or is it minus? First one squared in the front, second one squared in the back, twice the product of the two things in the middle, and then it's either a minus or a plus, depending on whether you've got a minus or a plus in the binomial. You'll notice that the last sign is always a plus. Okay, so we had seen those in multiplication of polynomials. We'd also saw them in factoring. And so the kinds of ways we use these formulas, let's just illustrate with a few examples. For x plus 7 squared, we know following the formula, this should be x squared, that's the first one squared, plus twice the product of the two things. X times 7 is 7x. Now times 2, that's 14x. And then in the back, we'll have 7 squared makes 49. Okay, for the next one, we've got y minus 9 squared. So we'll have y squared in the front. This time it's a minus. And then 9y times 2 is 18y. And then in the back, 9 times 9 is 81. So that's kind of how this is going to play out. Let's try one that's got a fraction in it. A plus a fourth squared. We'll have a squared in the front. We got a plus this time. And then 1/4 a, that's the product of the two things. 1/4 a, but you got two of them, so that's a half of an a. And then in the back, 1/4 times 1/4 will be 1/16. All right, so you can, of course, use just whatever technique you like to use to do multiplication of binomials. Some people like FOIL. You can use the distributive property, a handful of other methods. But when it's perfect square like this, you can use these perfect square trinomial formulas to get the job done. All right, we also saw we can use those formulas to help us with factoring. So let's try that. X squared plus 20x plus 100. We can recognize this as a perfect square because we've got x squared in the front, which is a square. 100 is a perfect square. And 20 is 2 times 10, right? So I'm kind of looking at it like this. This is x squared plus 2 times 10 times x plus 10 squared. I just rewrote it that way to make the pattern real obvious. So now this will factor as x plus 10 squared. All we're doing here is basically the reverse of those three examples at the top of the screen. Instead of multiplying, we're factoring. Okay, a couple of more. This one should be easy. I did this just a minute ago. This one will be y minus 7 squared. Half of 14 is 7. 7 squared is 49. In a way, knowing that middle term tells you automatically what the last one's going to be. Here, you can try this one. K squared plus 12k plus, if I'm going to do this the same way I did these last ones, what has got to be here? Well, 12, half of 12 is 6. 6 times 6 is 36. You need to have a 36 there in order for this to work out the same way. And this will factor as k plus 6 squared. V squared minus 8v plus, well, half of 8 is 4. 4 squared is 16. We should have 16 in the back. Then this will factor as v minus 4 squared. Okay, one with a fraction in it. we've got a squared plus a plus a fourth. So don't be scared, it's going to be all right. We have a in the front, and then in the back, the square root of a fourth is a half. 2 times a half is 1, so this fits the pattern. We've got a plus 1/2 squared. This one's got an odd number in the middle, but that's okay. Take a look at the 3. What's half of 3? Half of 3 is 3 halves. Do yourself a favor and don't turn this into 1.5. It's going to make your life a lot harder. Just keep it as a fraction. 3 halves squared is going to be 9/4. We need 9/4 in the back. And then this will factor as y plus 3 halves squared. All right, so this has been a really quick review of how you use these perfect square trinomial formulas to help you do multiplication and factoring. We're going to use them right now to help us with completing the square. Okay, so let's take a look. So we want to use the completing the square idea to help us solve this equation. We've got x squared plus 4x is equal to 5. So on this one, the left-hand side is not a perfect square. It's just x squared plus 4x. In fact, let me rewrite that a little bit and leave a little bit of room. If this thing was going to be a perfect square, and that's a big if because it's not, if this thing was a perfect square, what would you expect to see in that third spot? Well, half of 4 is 2. 2 squared is 4. We're going to add in that 4 that we needed. That's completing the square, and that's why this technique is called that. Of course, this equation needs to stay true, and so just because I added this 4 onto the left side, I had better add 4 onto the right side. Otherwise, I've changed the equation and it's not true anymore. Okay. All right, so then now the left side has been completed, right? So we can factor that. So this will factor as x plus 2 squared, and then the right side's 9. Now you can finish this using the square root property that we practiced. So we'll have x plus 2 equals plus or minus, and then the square root of 9 is 3. So x is equal to negative 2 plus or minus 3. Okay, so that will be negative 2 plus 3 is 1. Negative 2 minus 3 is negative 5. Once again, notice that here we ended up with rational number solutions, and so we could have gotten away with factoring on this one, as it turns out, if you had collected all of the terms onto the left side. Then you could have solved this by factoring. I wanted to do our first example where we could use both ways to get this done. All right, let's try the next one. Maybe we won't be so lucky. Maybe we won't be able to factor. We will try y squared minus 10y. And then in order to make a perfect square out of this, half of 10 is 5. 5 squared is 25. I'm going to add 25 to both sides of the equation to make it so that the left side is a perfect square. This will make it so we have y minus 5 squared, the left side, which is pretty great, and then 25 minus 9, 16 on the right side. Now then, this will give us y minus 5 is plus or minus 4. So that did it again. We've got rational zeros again. So we would have factored, or would have been able to factor. Tried. 5 plus 4 is 9. 5 minus 4 is 1. So our two solutions are 9 and 1. Okay, let's try this again. We've got m squared plus 8m, and that's equal to negative 19. I have a feeling we won't be able to factor on this one. Let's see what happens. Half of 8 is 4. 4 squared is 16. We're going to add 16 to both sides. On the left side, we'll have m plus 4 squared. The right side, we will have negative 3. So we're going to have complex number solutions this time, which is okay. M plus 4 will be plus or minus the square root of negative 3. M will equal negative 4 plus or minus the square root of negative 3. The square root of negative 3 is going to be I square roots of 3. So we'll have negative 4 minus I root 3 and negative 4 plus I root 3. Okay, a couple more examples to come. All right, here we have x squared minus 16x plus 16, that's equal to 0. So here half of 16 is 8. 8 squared 64, not 16. So you could, if you like, just add in what's missing to make the 64, but a lot of times people prefer to do the following. Instead of doing that, we're going to just subtract the 16 from both sides to create a little space. Either way will work though, of course. So half of 16 was 8. 8 squared 64. Okay, all right. So then the left side will factor as x minus 8 squared. And then the right side, 64 minus 16, I think is 48. Okay. And so, yeah, x minus 8 squared is 48. From here, it is downhill from here, plus or minus the square root of 48. X will be 8 plus or minus root 48. I'd better simplify the square root of 48. Square root of 48 will be the square root of 16 times 3. All right, sorry about that. Zoom crashed yet again. So sorry. Square root of 48 is the square root of 16 times 3. So we have the square root of 16 times the square root of 3. Square root of 16 is 4. 4 root 3. All right, this will give us 8 plus or minus 4 root 3 after we've replaced the square root of 48 by 4 square roots of 3. So 8 plus or minus 4 root 3. Okay, here's one for you to try. Why don't you take a minute, pause the video, try this one yourself, and then restart the video and see how you did. All right, so what I'm going to do is subtract the 9 from both sides to make it so that we have a little space there and just terms involving a on the left side. Taking a look, half of 4 is 2. 2 squared is 4. We should add 4 on both sides. Okay, now we'll have a plus 2 squared on the left and 25 on the right. I feel like we did this one already. A plus 2 will be plus or minus 5 on taking square roots. A will be negative 2 plus or minus 5. Negative 2 plus 5 is 3, and negative 2 minus 5 is negative 7. So once again, this one we could have done via factoring, but we didn't have to. All right, here's another one to try. J squared is equal to 5j plus 9. What you want to do first is collect everything, at least the two terms with the variable in it, onto one side and leave the constant term on the other side. So here we'll have j squared minus 5j, and that'll equal 9. So on this one, what is going to make this one a little maybe trickier is the fact that the coefficient of j is a 5, which is an odd number. So when you go to take half, you're going to end up with a fraction. And a lot of people don't like that. So let me do that off to the side on my scratch paper. So our coefficient of j is negative 5. To figure out how to complete the square, you first take half. When you take half, you're going to divide by 2. Taking half of something is the same as dividing by 2. And once again, you don't want to turn this into a decimal, even if it is tempting. If you divide 5 by 2 and get 2.5, your next step is to square 2.5. And you may not like doing that as a decimal, but in a fraction, it's easy. Okay, so we want to square our 5 halves. That will be 25 fourths. You square the top, you square the bottom. Okay, so we're going to be adding 25 fourths onto both sides. Okay, so now the left side is a perfect square. We know it is because we made it be that way, right? So you don't have to really try too hard to figure out what goes in the blank. It's j in the front and then a minus on this one. And then to figure out the back, it's either half of 5 or the square root of the pink thing. The square root of the pink thing is 5 halves, and that's the same as 5 divided by 2. So you have j minus 5 halves squared. Okay, and then on the right side, we have 9 plus 25 fourths. So we're going to want a common denominator there. That's 36 fourths. That's 9, isn't it? And then 25 fourths. J minus 5 halves squared. And then this is 50, 61 fourths on the right side. Okay, now we're ready to use this square root property. We'll have J minus 5 halves equals plus or minus the square root of 61 over 4. So we should get the square root of 61 over 4. That will be the square root of 61 over the square root of 4. And that's the square root of 61, which we're going to leave it like that. And the square root of 4 is just 2. J minus 5 halves is equal to square root of 61 over 2. And don't forget that plus or minus sign in there. Write that mildly better. Okay, last step is just to add that 5 halves to both sides. Okay, so J will equal 5 halves plus or minus the square root of 61 over 2. All right, and that takes us to the end of it, which is lucky because I was about to run out of paper. So it can be a lot of steps, but it's a pretty well-defined sequence of steps. Collect the variable terms and only the variable terms onto one side. Take a look at the linear term, that is the non-squared one. What's the coefficient? Take half, square that, add that to both sides, factor the left side, and use the zero product property, or sorry, square root property to finish. All right, we have a couple more examples to try. So for this one, we have x minus 2 times x plus 8 equals 11. And at first, it might be tempting to kind of think zero product property and go, okay, well, it's 2 and negative 8. But it doesn't work that way because the right side is 11, not 0. We have a zero product property. We don't have an 11 product property. So don't fall into the trap that we set for you. So what you want to do, or not want to do, but have to do, sorry, what you want to do is multiply out the left side. So this will be x squared plus 6x minus 16 equals 11. And then we're going to get this set up for completing the square. So let's add 16 to both sides. And so that will be 27 on the right. All right, so now that looks a lot better, a lot easier to manage. So we're going to add how much to both sides? Take a look at the number next to the x. That's a 6. Half of 6 is 3. 3 squared is 9. We're adding 9 to both sides. The left side factors is x plus 3 squared. The right side is 36. We'll have x plus 3 is plus or minus 6. And again, we're going to have rational number solutions for this. Negative 3 plus or minus 6. Negative 3 plus 6 is 3. Negative 3 minus 6 is negative 9. So we will have 3 and negative 9 for solutions. Okay, what's different on this one is that there's a common factor of 2 that we can remove. So we're going to first factor out that 2. This will give us x squared plus 8x plus 7. That's equal to 0. Divide both sides by 2. We'll have x squared plus 8x plus 7 is 0. Then I'm going to take that 7 and subtract from both sides. We'll have x squared plus 8x equals negative 7. So a little bit of algebra steps just to get it ready for us to complete the square. Taking a look at the number next to the x, which is an 8. Half of 8 is 4. 4 squared, 16. We're going to put 16 on both sides. Okay, now we've got x plus 4 on the left, squared. And then 16 minus 7 is 9, isn't it? So then we'll have x plus 4 is plus or minus 3. After applying the square root property, x will be negative 4 plus or minus 3. Negative 4 plus 3 is negative 1. Negative 4 minus 3 is negative 7. Okay. All right. Here's one for you to try. Take a minute, pause the video, and try this yourself and restart the video and see how you did. All right, so on this one, our coefficient of the squared part is 3. So it's tempting to look and say, okay, well, maybe there's a common factor. 3 and 21, okay, those both have 3 as a common factor, but unfortunately the 2 doesn't have 3 as a factor. So we're kind of stuck with it. So what you can do still, though, is divide all the way through by that 3. So let's go ahead and do that. We'll factor the 3 out. This will give us y squared minus 2/3 y. We've divided both sides. We're dividing both sides by 3. So we'll have y squared minus 2/3 y is equal to 7. All right, so in order to apply those two formulas we'd had, go back to those real quick. The two binomial squares formulas that we'd had, notice that the coefficient of the squared part is just a 1. It's 1a squared in both cases. And so if you were in the situation like this one, where there was a 3y squared, you got to get rid of the 3 if you're going to be able to use those formulas. So that's what I've done. I've divided both sides by 3. Now, it leads us with this coefficient of y that is negative 2/3, which you may not like, but that's the way it goes. We're going to have to deal with it. So taking a look at the number next to the y, which is negative 2/3, we're going to want to take half of that. So remember that to take half of a fraction, you double the denominator because you are really multiplying by 1/2. Okay, so this will give you 2/6, which is the same as 1/3. That's negative 1/3. Okay, so we've taken half of negative 2/3, that's negative 1/3, and we're going to square that. If you take 1/3 and square it, you get 1/9. So we're going to be adding 1/9 to both sides. Okay. So that was not so bad after all. Half of 2/3 is 1/3, 1/3 squared is 1/9. Added that to both sides. Now the left side should factor pretty nicely. It's y minus 1/3 squared. And then for the right side, we need to turn 7 into ninths. That's 63 ninths. 63 ninths plus 1/9 will end up being 64 ninths. And y minus 1/3 squared equals 64 ninths. And then notice that the right side, they've rigged it again so that it's a perfect square. So that's pretty great. So we have y minus 1/3 equals plus or minus the square root of 64 is 8, and the square root of 9 is 3. So it's plus or minus 8/3. We'll have y is 1/3 plus or minus 8/3. Okay, let me add. 1 plus 8 is 9. 9/3 is 3. 1 minus 8 is negative 7. We'll have negative 7/3. Okay, that one was a little bit much with the fractions in there, but make sure and take some time to look at it and figure out what exactly happened. Remember, with videos, the upside is that you can always rewind and you can slow things down if you want. So we have one more example and then we're done. So once again, take a minute, pause the video, try this one yourself, and then restart the video and see how you did. All right, so on this one, we've got 3y squared, 2y, and a 4. As before, I need that leading coefficient to be a 1. Instead, it's a 3. So we're going to divide both sides by 3. This will give us y squared plus 2/3 y. That's equal to 4/3. So this one, unfortunately, is going to be very similar to the last one we did because it's 2/3, but that's okay. Half of 2/3 is 1/3, and then 1/3 squared is 1/9. We're going to add 1/9 to both sides. Okay, then the left side will factor as y plus 1/3 squared. 4/3 plus 1/9. We need to turn 4/3 into ninths. So we'll multiply the top and bottom by 3. That will give you 12 ninths plus 1/9. That makes 13 ninths. Going through that a little faster because we've already done one exactly like that. Y plus 1/3 equals plus or minus the square root of 13 over 9. And so y will equal negative 1/3 plus or minus root 13 over 3. If you want, you can write that as a single fraction. Make that negative 1 plus or minus the square root of 13, then all over 3. All right, that takes us to the end of the completing the square. With completing the square, you can solve any quadratic equation by completing the square and then turning it into a problem where you can use the square root property. That finishes up this section. Let me know if you have any questions. Have a great day.